Okay. Today, still basic splice. Basic splice. Why basic splice? The reason is the basis we have obtained computationally not stable. Yeah, that's the reason. Yeah. Okay. Yeah. From the last class, we learned that a basis for this space is the following. But there is a drawback about this basis. When K is large, K is large. Much larger, much, yeah. This symbol means much larger, very large. Say for example, K is 100, 100. Okay. If X is also large, say 100, then this part compared to this part. Okay. Yeah, the numbers in this part much larger than the numbers in this part. So your computer consider this part all zeros. As a result, the computation not accurate. Too much round of errors. Yeah. So this is a big drawback. Now, we want to develop a basis for this space. The new basis doesn't involve powers. That's the point. Okay, that's the purpose. Okay. For a new basis, first we construct some basic splice. Yeah. B means basic splice. Okay. First, we extend the lots. Let's draw a real line. Yeah, this is a real line. Interval AB. Suppose the function f is defined on the interval AB. Yeah, function f. What is function f? The function f usually we don't know. Just from some experiments, we can collect some function values about this function. This function, suppose that is defined on the interval from A to B. Now we cut the interval into subintervals. This is the T0, T1, T2, and Tn. Right? Function f is defined on interval AB. And the spline functions in this space also defined on the interval AB. Now, let me extend the lots to negative infinity and to positive infinity. Yeah. So this is a Tn plus 1, Tn plus 2, and so on to positive infinity. And in this direction, we also extend the lots to negative infinity and negative 2. Okay, now we construct basic splice. Basic splice define basic splice. Define on this interval, okay, defined on this interval. After we construct basis splice, then from basis splice, we pick a basis for this space. Okay, now basis splice. Basis splice also piecewise polynomials. Degree 0. We first define basis splice of degree 0 first. That is the starting point. Basic splice of degree 0. On this subinterval, what is I? I say -2. If I is -2, then t -2, t -1. That means that is subinterval. Over this subinterval, bi 0. 0 means degree is 0. Splice function over each subinterval is a polynomial. Now degree 0 is equal to 1 on the interval. If x not in this interval, 0. 0. If x not in this interval, and see. The graph of this function is simple. Yeah. The graph. Yeah. Yeah. This is a ti plus 1. This is a ti plus 2. Ti minus 1. Over this interval close at ti. So close point. Okay. Horizontal. Open point. Yeah. The height of this line segment is 1. Then over this interval is 1. Outside the interval, 0. Yeah. This is a degree basic splice functions of degree 0. That means I need some always properties about this function are easy to see. Okay, easy to see. Properties. Number 1. Yeah. Bi 0 non-negative for any x between negative infinity and positive infinity. B, number 2, the support of Bi 0 is what support means. The set of x values where the function is non-zero. The set is support. The support of this function is this interval. Outside this interval, function value 0. Property number 3, important. Okay. Right. Summation Bi 0 x. What is I? I, any integer. Yeah, negative 1 million, negative 1 billion can be okay. Any integer. I integer from negative infinity to positive infinity is always 1. How to prove this property? Yeah, actually, these two properties very crucial. Okay, very crucial about this new basis. How to prove this? Yeah, prove. Arbitrarily pick x. Okay, pick x. Okay, yeah. This is a number line. Arbitrarily pick x. Then x will fall into a subinterval. Okay. Then x will fall into a subinterval j, tj plus 1. Okay. For some, I don't know what the j is, but for some j, okay. All right, now compute this sum. Compute this sum. I0. Yeah, this sum is equal to summation I from negative infinity to positive infinity. I not equal to j. Plus dj 0 x, right? Okay. But by definition, this is equal to 1. How about the bi in the sum? All the bi in the sum are zeros. By definition. So this is a 1. 1. Yeah. Number 1 and number 3 says that for any x, bi 0 x, always between 0 and 1. Yeah. It doesn't like a power. When x is large, the power very large, super large. But for any x, this function always between 0 and 1. It doesn't go up to infinity. Okay, now this is the starting point to construct basic splice. Okay. Now starting from bi 0, we can define bik. K is degree. Okay, now basic splice of degree k. Okay, degree k. Now the definition is again bik x is x minus ti plus k minus ti times bi k minus 1 lower degree. And then plus ti plus k plus 1 minus x ti plus k plus 1 minus ti plus 1 b I plus 1 k minus 1. We can simplify this expression a little bit. K ti bi k minus 1 x. I can rewrite this factor as 1 minus x minus t I plus 1. And then ti plus k plus 1 minus ti plus 1. And then b I plus 1, k minus 1. Okay, now let me denote this function. By simplify, by say according to the book by v. This v depends on I, also depends on k, x. Then after we introduce this notation, then this function will be v I plus 1. So here I plus 1. And then k. Yeah. Okay, now with v, then this is v I k times b I k minus 1, then plus 1 minus b I plus 1 k, and then times b I plus 1 k minus 1. Yeah, of course, I intentionally mix x. Yeah, let's consider a case when k is 1. Okay, k is 1. Yeah, a special case. K is 1, and see what basis spline functions look like. Say, consider a special case. Consider k is 1. Okay, then when k is 1, this formula is what? Is b I1 x is equal to x minus ti over here k is 1, so I plus 1 minus ti, then b I 0 x. Okay, that's plus k is 1, so t plus 2 I plus 2 minus x t I plus 2 minus t I plus 1, then b I plus 1 0. Yeah. When k is 1, yeah. This is this. And recall the definition of this guy. This is what? This is a 1 on the interval ti plus 1. Yeah. How about this? This is a 1 on ti plus 1, ti plus 2, right? Definition. So this is what? When x is outside the two interval, outside this interval and this interval, that means that less than ti, greater than ti plus 2, greater than or equal to ti plus 2. Yeah. Less than ti. So this guy is 0. This is 0. 0. Okay. Less than the let me draw a number line. Here a number line. x. ti plus 1, ti plus 2, ti plus 3. How about this? This is a ti minus 1. Okay. So x less than ti, say maybe here or here. So bi 0, bi plus 1 0, both 0. So this function is 0. Okay, now how about x is in this interval? Yeah, x is in this interval. Yeah. When x is in this interval, this b is 1, and this b is 0. So x minus ti over ti plus 1. The graph of this function is this. The graph here. When x is ti, function value is 0. When x is ti plus 1, function value is 1. So 1. Okay. 1. Here. Yeah. The number 1 is degree. Spline function is piecewise polynomial, degree 1. Degree 1. A line, degree 1. Okay, now if x is in this interval, yeah. Yeah. When x is in this interval, this b 0, and this b is 1. So ti plus 2 minus x. Now let me plot this function. When x is ti plus 1, this function is value is 1. When x is this point, function value is 1. Yeah. When x is ti plus 2, ti plus 2, function value is 0. Ti plus 2 minus ti plus 2, 0. So, yeah. How about the values outside from ti to ti plus 2? Function value is 0. 0. This blue curve is the graph of this function. So this function is piecewise polynomial, degree 1. Degree 1. Yeah, this is an example, okay, for a special case when k is 1. When k is 2, similarly, you can plot the graph of bi2. This is a basic spline functions. Yeah. Now, let me present properties about basic spline functions. Without proof. Yeah, because good treaties. Yeah. Properties. Yeah, definition is here. Okay. Starting point is bi0. And properties of basic splines Number one. Number one, this property is about the positivity of basic spline functions. Positivity of B-spline functions. Right. When K is 0, BI 0, greater than 0 on this interval. Yeah. This is definition. Yeah. Actually, the function value is 1 greater than 0. For other K, now K is 0. For other K, yeah. K is 1, K is 2, K is 3. For other K, then greater than 0 over this interval. If K greater than 0, okay, yeah. K is 0, then positive over this interval. K greater than 0, positive over that interval. So when K is 1, this guy positive over this interval. Ti to Ti plus 2. Ti plus 2 greater than 0. About support. Number 2. Support. Again, support is the set of x values where the function is non-zero. Support of basic splines. Okay. When degree is 0, yeah. This function is 0 if x not in outside this interval. What's the value? 0. That means that this interval is support of BI0. How about for general K? BI K is 0 if K greater than 0 and x not in this interval. Actually, property number 1, property number 2, very similar, closely related to each other. Okay, yeah. In this interval, function value greater than 0. Outside the interval, function value is 0. So this is support. Okay. Property number 3. About the loops. Now we have infinitely many loops. Actually, what we concern is T0, T1, T2 to Tn. We are interested actually only in these n plus 1 loops. On this interval T0 to Tn, only the following B-splines are not always zero. A spline always zero. That means that at any point in this interval, function value is zero. Not always zero. That means that at least there is one point here, function value non-zero. Not always. Over this interval, we have many basic splines, but only the following. Okay, not always zero. Okay, here. Also two cases. When k is zero, yeah, b 0 is function not always zero over this interval. B1 0, B2 0, and Bn minus 1 0, Bn 0. How about Bn plus 1 0? Yeah, this guy always 0 for any x in this interval. How about k greater than 0? For k greater than 0, b negative k, okay, non-zero. B negative k plus 1, okay. Yeah. B negative k plus 2, k. And then B m minus 1, k. If k greater than 0. How many functions? Here. How many functions here? How many? How to count the number of functions? How many? N minus 1, yeah. N minus 1 minus k minus negative k, then plus 1. So many functions. That is yeah. Cancel 1 n plus k. There are infinitely many basic functions, but only this n plus k over this interval, okay, from t0 to tn. Not always 0. Other basic functions on this interval always 0. The following one important, okay. The following topic. Property number 4. For all k is 0 or greater than 0, okay, for all k, and all x, any x, okay, we have summation bik x. What is I? Any integer I from negative infinity to positive infinity. Make some always 1. Nice, okay, nice. Yeah, this is why we use basic spline functions as a basis for the space. Yeah, this is very important. If we use a basis with power, power can, you know, go to infinity, but this basis not go to infinity. Very good problem. Right. Property number 5. basic spline functions. First, piecewise polynomials, and also smooth. Here, this is the here. Number 5. Smooth list of basic spline functions. For k greater than or equal to 1, okay. For k is 0, then the graph is 1, then 0, right? You can see a jump. But when k is greater than 0, okay, the B basic spline function BIK is in this space, okay, C k minus 1. That means that basic spline function, a basic spline function, you can take derivative k minus 1 times on the function. And the resulting derivatives still continuous. C means continuous. K minus 1, you can take derivative k minus 1 times. So this function smoothly order k minus 1, okay, everywhere. Yeah, it can be so that derivative BI x is equal to k over. Yeah. The proof is tedious. Okay, now we have basis splice. Now, from basis splice, let me construct a basis for this space Bn. The functions in this space, okay, functions in this space are defined on the interval AB. Go back to the definition of this notation. Spline functions of degree k, put them together. Yeah. The set below by this BNK. Yeah, this BNK and it's different. Okay, yeah, here maybe I use I say, yeah, don't be confused with this notation. Maybe, yeah. This notation is set of spline functions, not basic spline. Okay, now we have basic spline. I can obtain a new basis for this space. Yeah, here. The last property, number 6. Number 6. Basis for the space not B, but S, okay? No, I'm sorry, okay. S and K denotes the set of all spline functions of degree K, okay? This is a no, S. Good. Yeah. Otherwise, confused with these locations. Okay. A basis for the space S and K. Each function in this space is defined on this interval. Let me restrict the definition to T0, Tn. Okay, yeah. T0 to Tn. A basis for this space is the following. Yeah, is the following. Basic spline K. Negative K. Yeah. This function, basic spline, defined on relative infinity to positive infinity. Now, let me restrict this function to this interval T0, Tn. And then the next one, Bk plus 1, K, restrict this to Tn, T0 to Tn. And yeah, the last one, B n minus 1, K. This is a new basis. Yeah, this new basis, low power, and also function value of each basis function. Yeah, basis function. Function value always between 0 to doesn't go up to infinity. Let me explain with tracer. Okay. If we have a function defined on some set, say defined on set D, okay, D. Okay. Okay. Now I have okay. Now I have K. K is a subset of D. Subset of D. Yeah, this is a D. Okay, D. K. Yeah, K. Yeah, K. Subset of D. Then this notation F K means restrict the function its domain to K. Okay. Bring down the domain from D to K. The definition is this. And if X is in K, then the function is F of X. If X outside K, then this function undefined. Undefined. So here, this rotation means when x is between T0 and Tn, this guy is equal to b negative k x. When x outside this interval, this guy, we don't define value for it. Yeah. Yeah. Definition. Okay, now we have a new basis. In fact, commercial software uses this basis to do spline interpolation. Now, Wednesday, I use the new basis, to interpret a spline function to a given data set. Wednesday. The resulting linear system, very stable, very stable. All the entries, they have sizes about the same order. Yeah, always between 0 and 1, about the same size. It doesn't lie a basis with a power. Some entries, billion. Some entries, just 1, 2, or 10, right? So billion compared to the tens, the thousands, the hundreds, tens, thousands, hundreds, computers consider them zero. This is job. Okay, then see you Wednesday. See you Wednesday.